So 2.3 says, for which values of n will the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? So just to recap, in 2.1 we had a quadratic expression that had a general term of Tn is equal to it was 3n squared minus 8n plus 7. Then in the previous question we didn't find the value of Tn, but we did know what the a was. So in the previous question you can see that the a was 35 and the d was minus 7. So a was 35, d was minus 7. This is all the information that we need from 2.2. So read our question again, and it says, for which values of n, so we're looking for n, will the sum of the first n terms of the arithmetic sequence in question 2.2, so this one, be equal to the nth term of the quadratic sequence in question 2.1, which is that. So we are looking for a certain position where the sum, or there's a certain value within the progression of this sequence, the quadratic sequence, that at some point we will have, let me just do it like this. At some point we'll have a term Tn that has a value such that that value is equal to a certain amount of numbers here. So this value in the quadratic pattern will be equal to the sum of a certain amount of numbers within our arithmetic pattern. So that's what we're looking for, and the proof would go something like this. We first need an expression for the sum of the numbers in 2.2. So using the formula n over 2, 2a plus n minus 1d, we can make a few substitutions. Seeing as we don't know what n is and we're trying to solve for that, we leave that alone. A, we know that's 35 plus n minus 1, d is minus 7, and then we simplify this as much as possible to get n over 2, 70 minus 7 n plus 7, like that. Then we can further simplify this to n over 2, 77 minus 7n, and leave it at this point for now. Then we can come over here, and we've already written our general formula, which is Tn is equals to 3n squared minus 8n plus 7. So what we are saying is that there's a certain n value at which these two will be equal, that the sum of a certain amount of numbers will be equal to the nth position. For example, theoretically or hypothetically, we might be talking about the position 67. So at 67, term number 67 in the geometric or in this quadratic pattern will be equal to the sum of the first 67 numbers in the arithmetic pattern. So in order to find that number, which might be 67 or not 67, we have to equate the two formulas together. So 3n squared minus 8n plus 7 will be equal to that. or rather let's write that on a new line where we are saying Tn for quadratic is equal to Sn for the arithmetic. This will be 3n squared minus 8n plus 7 is equal to n over 2, 77 minus 7n. Multiply both sides by 2 to get rid of this fraction. We get 6n squared minus 16n plus 14 is equals to n bracket 77 minus 7n. Then we can multiply out this bracket. That will be 77n minus 7n squared, and we can bring this to the other side in the next row. And since it's getting clustered, I can skip a row. And taking 7 minus 7n to the other side, we get 6n squared plus 7n squared. That gives us 13n squared. Then minus 16n minus 77n, that gives us minus 93n. And then this 14, there is no other constant, it will just stay plus 14 is equal to 0. Then if you're brave, you can try and solve this using the brackets. But the better and smarter way would be to solve this using our quadratic formula. So that would be b squared minus 4ac all over 2a. Then we substitute our values again. This is a, that is b, and that is c in their entirety. So don't forget to substitute with the sign. In this case, b is negative 93. So be careful with the signs when substituting. Plus minus negative 93 squared minus 4. A is 13. C is 14. This is all over 2a, which is 13. This is equal to either, and this is a common mistake that I just made that most people do. Here we are not solving for x, so it's best you use the variable that you're solving for, and it's a common habit to write x since we're mostly always solving for x, but in this instance we are solving for n, so make sure that is n. Then computing this onto your calculator or using your calculator, you get n is equals to 7 or n is equals to 2 over 13. But we can't have n being a decimal value or this kind of fraction that can't simplify to a integer value. So what we do is we say this one's non-applicable. The only type of answers we want is answers where n is greater than 0. Because this is describing position, we can't have a position that is being described by a decimal or position described by a negative number. Therefore, when n is 7, this here is true. That means the 7th term in this pattern will be equal to the sum of the first 7 terms in the arithmetic pattern.